Alright, I'm just going to wrap up sections 12.1 and 12.2. Just a quick summary here of all of the exponent rules in those two sections. We've got our exponent of 1, exponent of 0, product quotient, negative exponent rules, there's two of them, product to a power, quotient to a power, and power to a power. So we've seen all these rules, now we're going to put them to use. I'm going to run through, I think it's 6 different examples, and show you a variety of different things you can do with these rules. Okay, so the first one is to simplify, and these are all going to be simplifying exponent expressions. And so the first one is to simplify here 6y to the 4th times 5y to the 5th. To do this, because everything is a multiplication, I can rearrange the factors so that I'm multiplying the constants and the y's together. Okay. Now 6 times 5 is equal to 30. Y to the 4th times y to the 5th. To do that, we're going to utilize the product rule where we add the powers, right? We've got a product where the bases are the same. Product where the bases are the same, you're going to add the powers, you get y to the 9th. And that's it. It's as simple as it gets. Next example is going to be to simplify x to the minus 1 times x squared over x to the 3rd. Now my own personal preference is to eliminate all negative powers when I see them. We generally don't like to work with negative numbers. It's just less convenient, I guess, or easier to make mistakes. And so I'm going to utilize one of the negative exponent rules to take this negative power and move it to the denominator with a positive power. And so I can do that. I'm going to have, so that factor moves down. The x squared stays on top. The x to the minus 1 goes to the bottom and becomes a positive 1. That's our negative exponent rule. And then the x to the 3rd stays on the bottom. Okay. Now, on the bottom I have two factors of x that I can multiply together. Well, multiplying results in adding the exponent, so that becomes an x to the 4th. And now using the quotient rule, I can subtract my powers. 2 minus 4 is x to the minus 2, and of course using my last negative exponent rule, I can write x to the minus 2 as 1 over x squared. Our answer should always end up with positive powers, no negatives and no zeros. Okay. Alright, next example is to simplify this fraction. It's quite a bit bigger than the last two. Again, I'm going to start by moving all my negative powers and getting rid of any zero powers. So watch as I do this. I'm going to take 7 and x squared. Those are going to stay on top because they don't have any negative powers. Well, I'll come back to that. The 28 stays on the bottom. X to the 0 is really a 1, so I'm going to multiply by 1. Then I still have a y on the bottom because its exponent is positive. Now these next two I haven't written in yet. Those are the ones that are a little bit weird. Y to the minus 2 actually moves to the bottom and becomes y squared. It's positive 2 on the bottom. Z to the minus 2 moves to the top and becomes z squared. That becomes positive on top. So when you move a negative power, it becomes positive on the other side. Once I've eliminated my negative powers and my zero, I can go through and combine whatever can be combined. I can get my y's together, and I can combine the 7, the 28, and the 1. Alright, the x squared stays on top. The z squared stays on top. When I simplify 7 over 28, I get 1/4. So I need a 4 on the bottom. Alright, so I'm just reducing that down to a 1 and that down to a 4. The 1, if I multiply by 1, I don't change anything. So 1 times 4 is 4. I'm just going to leave the 4 there. And then here, y to the 1 times y squared, I got to add the 1 and the 2 powered, and I'm going to get y to the 3rd. That's the final answer. Nothing else can be combined or simplified there. Okay, example number 4. This one utilizes the product to a power and the power to a power rule. So if you have a power on the outside of a product, you distribute it to both factors inside. So 6 squared times, now x to the 3rd squared is like having a power to a power. So I've applied the 2 power to both factors. Now I'm going to simplify each one. So 6 squared, 6 times 6 is 36. And x to the 3rd squared, the 3 and the 2 multiply because we have a power to a power. So that's x to the 6th. 36x to the 6th is as simple as we can get. Okay. Alright, these next 2 examples are quite a bit longer. Bigger fractions, more exponents. Alright, and we're going to start, let's see. Again, inside, I guess we're going to follow the order of operations. Should always do that if we have, or if we have the choice. I'm going to look at this parenthesis as my first operation and look at the stuff inside. Do the stuff in first and then do the exponent second. Inside, this b to the minus 1 has to move to the denominator, and when I do so, it makes a positive power. So this becomes 2a squared on top. Still have the b squared on the bottom, but now this b to the minus 1 becomes a b to the positive 1 on the bottom, keeping my 3 exponent on the outside. Now the 2 b's on the bottom, b times b, ends up using our product rule where we add the 2 powers together. So this becomes 2a squared over b cubed, all cubed. Okay, now I'm going to utilize a combination of the product to a power and quotient to a power. I'm going to apply this 3 power to every factor in the parentheses. I'm going to get 2 cubed. And now when I apply the 3 to the a squared, I can multiply. It's a power to a power. So I multiply the 3 and the 2 and I get a to the 6th. And here b cubed cubed, power to a power, multiplies, and I get b to the 9th. Final step here is I can evaluate 2 to the 3rd, that's 8. So it's 8a to the 6th over b to the 9th. And that's as simple as we can get it. Okay, final example. This one's really big. You'll see several of these in your homework, I assume. And again, I'm going to start inside the parentheses, work my way out, moving the negatives first. So I'm going to turn this into anything that's positive power I'm going to leave. So the 6 and the y stay on top. The y to the 3rd stays on the bottom. And everything else changes. So 4 to the minus 1 becomes 4 to the 1, or just 4. X to the minus 4 on the bottom becomes x to the 4 on top. z to the minus 2 becomes z to the 2 on top. Now on the bottom, this x to the minus 4 becomes an x to the 4 on the bottom. And this z to the minus 2 becomes z to the 2 on the bottom. Alright, and so now I can start combining my common factors. So 6 times 4 gives me a 24. I've still got my y. Oh, I shouldn't have written that. Yeah, well, that's okay. I'll just scribble it out. Pretend that's not there. When I combine my y's, y divided by y to the third, if you subtract, think of that as a 1 power. 1 minus 3 is negative 2, or I can write it as y squared on the bottom. So I'm going to have a y squared on the bottom. And then, let's see, the 4s, or x's, sorry, x to the 4th and x to the 4th, that's the same thing on top and bottom. Those are going to cancel. Same thing with the z's. Those cancel. And so this is really all I have left. I wrote that kind of big. So actually, let's just rewrite this so I don't have to mess with that big fraction. This is really 24 over y squared raised to the minus 1. Now the minus 1 power applies to both factors, so think of this as 24 to the minus 1, and y squared to the minus 1 is like y to the minus 2, right? You multiply the powers. And so finally, to get rid of the negative exponents, I'm going to swap these. I'm going to put 24 down to the bottom, right? 24 to the minus 1 becomes 24 to the 1 on the bottom, and y to the minus 2 becomes y squared on top. And that is the simplest form. Main thing you guys need to remember as you're working through these is work inside out. If you've got parentheses and you can simplify inside, do that. Try to get rid of your negative and zero exponents first by moving things around or canceling, and then combine them using the product and the quotient rules, adding or subtracting the powers, and that should get you a pretty good start on these problems.